Or I can just record. And I'm gonna post this end of the day. So you guys have an idea. You can watch it and just see exactly what is going on.
Thank you.
So imagine that you have here a T section with some reinforcing. You're gonna have top reinforcing, bottom reinforcing, right? Also, I'm gonna give you a beam with some loading, which means you should expect dead load, live load. You're gonna do the load combinations, find out the ultimate load that you need to use in your design. For this, it says here, determine the design uniform load on the beam. How do you do this? Oh, ultimate load. You do 1.2 dead plus 1.6 live, compare it with 1.4 times the dead load, and see whichever covers. It says here, determine the design moment and design shear. What is a design moment? Maximum moment, right? What is a design shear? It's giving the shear at the critical section. So it is not the reaction. Please remember this. You see here 15 points. You do this correctly, 5, 5, 5. You miss one of them, you just lose 5. What is AV? Anyone recalls AV?
Isn't that the cross-sectional area between the cables?
Between the tie legs, right? Okay. Total cross-section area of the tie legs, right? For one set. Now, question: do you need really to do any calculations for this? No. I'll give you the section with the reinforcing, right? I'll give you the section with the ties. And your job is to figure out what AV I have provided. I'm not asking the required. I'm asking what is provided for you. Quick example on this. Remember this beam? How much was provided in the section? You're gonna say, well, I have 2 number 4, right? So it's gonna be 2 times 0.2 is gonna be 0.4 square inches. So it's gonna be that simple. So I'm not asking you to run any analysis. You don't do the concrete strength. Not needed here for this problem. But I'm not gonna give you something like that simple. It needs to be something a little bit more complex, right? I may give you 3 legs, 4 legs. You figure it out. So go to the first 3 items. It says here for this tension reinforcement is going to be shown to you. Let's say, if you like to look at this example, let me put it back. How much is the tension reinforcing? Can someone help me here?
3 number 8s.
Okay, very good. You say 3 number 8. This is all what you need to do. For this 3 number 8, ignoring the concrete flange. What do you mean by ignore concrete flange? Which means treat it as just rectangular section. This is all what I'm saying, right? And ignoring the compression reinforcement. This compression reinforcement, just ignore it as if it is not there. And then do the following. What's the first one? Cracking moment. You remember the cracking moment? Yeah, okay. Determine the depth of the concrete compression block, which means A and C, neutral axis. This is gonna be A and C. And then do the strain in the steel and do P factor. This can be so simple problem. You have a rectangular section with tension reinforcement only. How about the T? Ignore that you have a T. How about the compression reinforcement? Ignore it in this problem, in problem number 2. For each one of them, you have 5 points. You can run through this. All right, now let's see here, problem number 3. You consider the concrete flange effect, which means now you treat this as this is now a T section, and you ignore the compression reinforcement and do the same. So, okay. Last problem here. For this tension reinforcement, I'm gonna say replace it. This tension reinforcing, right? Let's say that here you have 3 number 8. So this problem would read, let's say, for tension reinforcement of 4 number 9 instead of 3 number 8. So what's 3 number 8? The one I provide here in the section. So what is the new value? I'm gonna put it here. Let's say 4 number 9 or whatever. It's gonna be some number there. And ignore the concrete flange effect. Consider the compression reinforcement. Now you treat this as a rectangular section with some compression reinforcement. No T effect. So it's gonna be one section, same reinforcing, tension compression, except for the last one when you change it a little bit. This section is going to be given as T. At one case, I'm going to say ignore the T effect, ignore the compression, then consider it, and so forth. And this is exactly everything that you guys have done between now and between the shear lecture, except for determining here this A sub V. Any questions? Because with this, I'm done with the review for the numerical problems. This is going to be it.
For the cracking moment on problem 2, can we, is it optional to do it as a Fluxure formula or that internal
It's up to you.
It's up to us? Okay.
Yeah, but if you have T section, yeah, it's going to be up to you. I'm going to leave it for you. This is your chance to ask me questions now.
So this is all the exam is going to be?
No,
No, and then there's going to be
there's a little parts going to be conceptual, some questions, and yeah. And what I'm thinking about, maybe the conceptual part, maybe you can do it on Proctoria. It's going to be like some information we're going to be going through it now. So are we done with this? Any other questions? Now this is going to be recorded. I'm going to post it on YouTube. You can watch it. So you don't have to type any of this. You can just stop video clip and see exactly what's needed. All right?
How much time are we going to be given for the exam? So you said you might give us a factorial session. So how long will we have for factorial and how long will we have for this portion then?
Okay. I'm gonna split it while we're talking now. We're gonna see exactly how long you think that this is gonna be taken versus the other one. Other one should be simple. Let me walk you through it. In this introduction, if you remember, this is the first slide set number 1. And we were talking about different type of concrete. We have plain concrete versus reinforced concrete. And you guys understand the difference, right? Can someone remind me here? It's gonna be a good review for you guys before the exam. What's the difference between plain concrete and reinforced concrete?
Reinforced has rebar installed or even some fiberglass.
Yeah.
Plain concrete is just a simple mold of concrete.
Okay, can you read this, please?
Concrete without reinforcement or with reinforcement ratio less than the minimum required by code.
Okay. So if you have some reinforcing, but it is lower than the minimum required by code, you cannot call it reinforced concrete. So remember this. What is the common types of cement that you're going to see out there? The very common one.
Type 2 and type
2 and
5?
5.
Yeah, this is a type of cement. But how about this cement? Portland cement is a very common one, right? Under this Portland cement, you're going to see here type 2 and type 5. It's going to be 2 and 5. You put a box here. Where do you think type 5 is going to be needed? Mostly.
High sulfate.
Yeah. So when do you think this is going to happen? In what type of construction?
Especially by the shore. By the...
And also for foundation, usually for foundation. So let's say for lots of locations, you're not close to the shore, you're not in the ocean or the beach, you're not doing any, let's say, offshore construction. But because you have lots of sulfate in the soil, you need to add this type V to the cement for the foundation, for the concrete. This is very common here. We use it a lot. Type 5 for foundation. You guys heard about fly ash, right? And the silica fume. You remember the fly ash and silica fume? Why are we using it?
Are they do they help resist
don't they help prevent corrosion in the concrete, like fly ash or zeolite or any of those? Like if you mix it with certain types of concrete mixtures.
Well, in this sense, you can say the cement is doing the same effect. But look here on the top, it says cement. And then I listed fly ash and silica fume, but they are not cement. But they are cement substitute.
Added into like the concrete mixture.
Yeah, so what is the problem with the cement? Why don't we like the cement and just use it? Why are we using this fly ash or silica fume?
Cracking.
To fill in the cracks.
Yeah, because cement is high shrink material. Shrinkage is high. When the cement is shrinking, you're going to see lots of cracks. The good thing about the fly ash and silica fume, they don't shrink that much. Lower shrinkage material. So you'd like to use it. It's going to be reducing the amount of shrinkage, reduce the hair cracks that you're going to see in the surface of the concrete. And they're cheaper. In the past, I have been told that in the 70s and 80s, silica fume and fly ash were just free. You just go there, pick it up from some industrial places, and you just use them, you add the concrete, now they sell it. But much cheaper than cement. So we should expect a question here about fly ash and the silica fume. Also, you should expect about the type of cement, which means type 2 and type 5. What is the use of this type 5? Fine aggregate and coarse aggregate. There's a very important thing that you need to be sure of any aggregate. It should be clean of clay and any organic materials. So I'm going to box this for you. Try to memorize this. And also clean of chlorides. This is going to be very important for you. Why? Because it has any chlorides, it's going to be rusting the reinforcing. Also, it needs to be graded. So the grading is going to be very important. Graded means you don't have them all of the same size. You need to be of different size. So interlocking is going to happen between particles. So I have here 3 important features that you need to see in aggregate, generally speaking, not just in fine aggregate and coarse aggregate. No chlorides, clean of clay and organic materials, and to be well graded. So we talked about the aggregate, we talked about cement. We talked about silica fume and fly ash. Plain concrete versus reinforced concrete. So for example, in this discussion here, if you mention that the plain concrete has no reinforcing, it's going to be half point. You need to say no reinforcing or reinforcing lower than the minimum required by code. How about here? When you have more than or equal to the reinforcing required by code. What is the unit weight of concrete?
150.
Range. I'm gonna say for normal weight and lightweight. So what is the normal weight? Is right here. Lightweight is gonna be right here. So what is this? This is gonna be the weight of the aggregate itself. But this is here is gonna be unit weight of the lightweight concrete. It ranges from 110 to 115. Normal weight 145, maybe 150. So I'm gonna say unit weight of concrete. Why are we using admixtures? I'm gonna say list. I'm gonna say maybe 3 reasons, 5 reasons. I'm gonna leave it here for you to list. Be careful, do not repeat reasons. So if you feel that you're confused and these 2 reasons are close to each other, instead of adding, let's say the problem is asking here for 5, try to make them maybe 7, you know, add more if you can. Just in case if 2 of them is kind of matching or the same meaning, you need to lose a point for this. You're gonna see more reasons here. If you look it up, if you search it online, you're gonna see more reasons to use admixtures. It's gonna be so simple for you. What is the maximum concrete strength that you can use as normal weight in construction? Can someone help me with this?
That would be 5,000, right?
Where is this at? How do you see?
Where it says maximum FC prime PSI.
When you have normal weight concrete, normal weight,
Oh,
normal weight.
there is it. Mhm.
How about
10,000? 10,000?
lightweight? No limit. If you're doing gravity. If you're doing here gravity, you don't have a limit. If you're doing seismic, it's gonna be 5,000 for the minimum, maximum. If you're talking about the minimum, we have some values here. So the information I need from you, since now you're trying to memorize the stuff, right? You're not gonna have this handy while you're answering. It's gonna be most likely about the maximum. So you need just to know that if you're doing gravity, there is no limits for normal weight or lightweight. When you do seismic, so this is gonna be called here seismic, like moment frame is gonna be structures resisting seismic forces. Normal weight, no limit. Lightweight, 5,000. So the number that you need to memorize here is gonna be 5,000. What are the available grades for A615 steel? STM A615 steel, right? Reinforcing. Available grades is gonna be right here. 40, 60, 75. What does mean by grade 60 for you? What's grade 60? I'd like to hear it from you guys.
Yield strength is 60 KSI.
Very good. That's all what you need to do. So you're gonna see a bunch of these questions. And I would imagine that all of these questions can be taken maybe 5 to 10 minutes max of your time. So if we need to do Proctoria, I can have this to be 5 to 10 minutes. And I don't really need to have it on the same day. We can do it in any other day, on the following day, right? We can do it on Thursday.
Sounds good.
Yeah, so we can decide on this. So I can split the exam because I don't want people to go and log in and use Proctoria. All of a sudden now I need to restart my computer. I need to switch to Zoom and all of a sudden I'm in trouble now. I don't want to see this happening. So
That sounds better. That sounds better, Professor, if we split it up in 2 days.
yeah, so I'm gonna say the conceptual part or theoretical questions, I'm gonna have it in a separate day. So you don't have to worry about it now. But for now, just concentrate on this. All right. Now ask me questions. You can ask or you can just go and study.
Can you give an example of what kind of conceptual questions you're gonna use?
Conception?
Mm-hmm.
I just said them. This could be the stuff that you're just talking about here.
Mm-hmm. But I'm referring more to kind of like the diagrams and finding f prime of c and
Okay. I just give you the exam. What do you want? Just review what I have talked about here, and you should.
okay.
Okay. No, any,
Professor, will you be uploading the old homework solutions?
which homework?
3 through 5.
3 to 5. Now let's talk. Let's see what is available and which ones you need. Give me a sec. Have you seen this already?
Yes.
Has everybody? Who's asked me? Was it Omar? Who's asked me a question a minute ago?
Yeah, it
Well,
was
homework.
me.
Okay.
Homework 5 was salute.
Did you see this, Omar?
Yeah, I'm just seeing it right now. But what about 3, 3B, and 4?
3B. What's 3B about? So which one did I post? I posted 2. Am I correct? This one?
Did homework 2.
So only homework 1, 3, 3B, and 4 are not posted. 2 and 5 are posted.
I see your solution to 2. Also set 4.
Where's the posted solutions located? Because I don't see it on.
This is 3B, isn't it?
No, but I don't see it on on Canvas. Is it under assignments?
You don't see
It's
him?
on the actual. It's on the actual assignment. Like you have to click on the assignment on Canvas, and then it would show it.
Oh, you have to click on the actual.
Mhm.
Oh, I see it. Okay.
So which one you have it already on Canvas?
The last one that was assigned over the weekend's on there.
5A? 5A, right? So the one
Yeah.
you already is 5.
That one's there.
Okay. I guess if you have this one, this should be a very comprehensive one. Okay, how about this one here? Because it has mods rupture and the cranking, right?
I don't think that one's on there.
It's still not on there.
Basically, we only have 2 and 5A.
I guess 4 is so simple, right? Do you need this? Well, we are videotaping it now. We are recording. Do you really need this? Don't think so. But anyways, it's recorded, so you can see it there. So I'm gonna put either 3 or 3B. One of the two.
You mind putting 3B, please?
Sure, I'll put 3B. But also I want you to know that you have detailed examples in the presentations. You have detailed examples, solve it completely. So you have this, which is the same as 4, right? And this one here, you have rectangular section. This one also is very detailed, especially when you change this to 3 inches and then you make it rectangular versus concerned. And this one also, look at this. The one that has 2 notches on the top, which is this one here. This is a very detailed solution to it. For the uncracked, you have the rectangular, and then you have the T section, right? And you have this example here. So actually, you have everything you need, but this is fine. I'll put 3B. I'll put it there.
Work for Tuesday's midterm. I'm assuming that you'll provide a link to upload our
Yes.
our work. Would you like that as a scanned document, or is a picture okay?
No scan, please. I mean, how do you take pictures? What do you use to take pictures?
Just my phone.
What phone? Yeah. Do you have Android or do you have an iPhone?
The iPhone.
The iPhone has an app that you could actually scan, and you scan all the pages and it'll turn it into one PDF.
Yeah. There's an app, or you can use notes. You know, in the iPhone, it says notes, and then you can take picture and picture of it. It give you a very good quality. It doesn't look like a picture. You're not gonna see lots of shading in it. It's very clean.
Or use Dropbox.
Dropbox. No, it's gonna be like a link. There's gonna be a link in Canvas that you can upload to it.
Mm-hmm. And then, Professor, for problem 2, just to clarify, when it says ignoring the concrete flange, that means it's rectangular.
Yes. So
And then
let me share this. This is here a T section, right?
Mm-hmm.
When I say ignore the T section or ignore the flange, it means consider your section to be like this. That's it.
Mm-hmm.
If you have top reinforcement, yeah, second, I can give you also another example. Let's say here's your section, right? Oh, doesn't have T here. Here's one concrete section, okay? That's top reinforcement, bottom reinforcement. So if I said here, ignore the top reinforcement, right? So it means just cross this out, as if this top reinforcement is not there. If we say consider it to be ignore the T, just give your section here. Okay? Ignore the top reinforcement, cross this out.
Okay.
But if I say consider the top reinforcement and ignore the flanges, so it means do something like this.
Okay. So meaning only just the bottom has the reinforcement, and then if you have to consider it, then you consider the top one as well, making it a T.
Yeah.
Okay.
So the depth is gonna be like 26 by 18.
What?
The area will be like 26 by 18. If we do the rectangular section, we're taking the depths to be 20. Oh, 20, I mean, sorry.
20, yes. In this case, give you the total depth. Ignoring the flange doesn't mean bring the beam to here, right? It means that this is give you your beam. Okay? This is what we call the flange. It means that this part here, just do not consider it. You can say this green one. It is not part of our business. This piece or this piece. And our section is giving only this piece here in the middle. If I say ignore the flange. All right, again to confirm. This is gonna be our full midterm that you're gonna be seeing on Tuesday. Okay? You need to have your camera on. And the conceptual questions or theoretical questions is gonna come in a later day, and I'm gonna call it a quiz. It's gonna be a separate quiz.
So the shear stuff that we're going over is going to be for the next midterm?
It's gonna be for the quiz. The stuff, what stuff? Which is about the cement type, about the concrete strength, about the unit weight, and 3 features, the aggregate, silica fume, and fly ash. This is giving the quiz. It's gonna be a short quiz, 10 minutes. So it's gonna be part of your lecture.
Professor, for the actual exam, we should like basically see something similar to that diagram that you had, or that you were demonstrating earlier, like something similar.
Something similar to this, or similar?
No, like to that, yeah. Like
yeah, it's gonna be something similar to this. Yes.
Okay.
And then, Professor, you're gonna provide us the formula sheet so we don't have to do them beforehand.
Yes.
Okay.
Will it be the same cross-section for each question, or will there be different cross-sections for each question?
It's give you the same cross-section. It's gonna be one cross-section, and at one time you're gonna be ignoring the flange, one time you ignore the top reinforcement, one time, so it's gonna be for the same cross-section.
Oh, okay, thank you.
No problem.
is that formula sheet on
You do
Canvas?
AS, so you do AS once, you do AS prime once, right? You don't keep on changing them. It's giving just the same value. Go ahead, Uzayf.
I'm sorry?
Go ahead, you're asking a question. Okay?
Oh, the formula sheet that you had, is it on Canvas?
I'll put it on Canvas. I'll put it very soon, so that
Okay.
information is available there.
So it's a closed note test if you're providing the formula sheet, right?
Yeah, I'll have the formula
Okay.
ready for you. It's
Sounds
getting
good.
up like this. She's gonna have this type of equations, the bar size, load combinations, this type of equation. You remember this equation?
Yeah.
Yeah, so you're gonna see it there, this equation, this chart. Okay, any other questions, or you're good?
Sorry, Professor, you said we have to use that equation, right? So can we use we could use you said we could use Excel or no?
No, you cannot.
Punch them in?
You cannot.
So we have to do it by hand?
Yeah, it needs to be hand, it needs to be calculator. And you cannot use metric. You cannot use SI system. Remember this, no metric, no SI system. If you do it, you lose points because all our equations here are based on US system or imperial system. Remember this, please.
So for the first question, it says determine the design uniform load on the beam. Is it like live load and date load thing? The one you do the the 1.2.
Yeah, like this. You remember this?
Yes.
Something like this.
Okay. Okay.
Slide set 7 has a good example on the loads. Be sure that you know how to do the design shear. It's going to be a D distance. This is what you call here critical section for shear, if you remember.
Yes.
All right, you guys have a good luck.
Thank you. Have